Problem 6. Let's first draw the triangle ABC. We know that AB equals BC equals 29. So if we draw a vertical line from A to BC, it crosses BC at D, then we will have BD equals DC equals 1/2 BC, and that equals 21. And because ABD is a right triangle, therefore AD can be calculated as square root of AB square subtract BD square, and that equals 29 square subtract 21 square and take the result square root, and that equals 20. So the area of ABC equals AD multiply BD, and that equals 20 multiply 21 equals 420. Problem 7. Let's assume there are two boxes A and B. A contains 3 chips numbered 1, 2, 3, and B also contains 3 chips numbered 1, 2, 3. And if we need to choose one chip from each box. If we choose one chip from A, that's 3 choices, and then we choose another one from B, that's also 3 choices. 3 multiplied 3 equals 9 choices in total. And if we would like the product of the two numbers to be even, then one number has to be even. So there's only number 2 that's even in each box. If we choose number 2 from box A, then we can choose any number in box B. That's 3 choices. And if we choose number 1 or 3 from box A, that's 2 choices. Then we have only one choice in box B, that's 2. So we need to plus the more choices from the odd numbers of box A. That's 5 choices in total that we can make the product even. So that it's 5 out of 9 choices for the result to be even. The answer is E. Problem 8. Because for a triangle, the length of the third side has to be less than the sum of the other two sides' lengths. So that means if we assume the third side length is L, it has to be smaller than 5 plus 19. 5 plus 19 equals 24. So the perimeter of the triangle has to be smaller than 5 plus 19 plus the third length is smaller than 24. So the perimeter has to be less than this sum, and that's 48. Therefore, any integer equal or larger than 48 will be larger than the perimeter of any triangle with a side length of 5 and a side length of 19, and the smallest one is 48. The answer is D. Problem 9. Because Janabel sold 1 widget the first day and 3 the second day, 5 widgets on the third day, and each succeeding day she sold 2 more. So let's write down the days and the widgets she sold for each day. We use D for days. 1, 2, 3, till the 20th day. Or maybe we could write N for the nth day. And for the widgets she sold, the first day is 1, the second day is 3, then third day is 5. So the nth day should be 2n subtract 1. And the 20th day will be 2 multiply 20 subtract 1. Now let's sum the 20 days widgets she sold. Let's sum from 1, 2, 3, 5 till 2n subtract 1, where n equals 20. And we can combine the first and the last term in the summation and the second term to the second last term in the formula. That's 1 plus 2n subtract 1 divide 2, multiply the total number of days, that's n, and we can cancel this out. That becomes n squared, because n equals 20, so it is 400. The answer is D. Problem 10. How many integers between 1000 and 9999 have 4 distinct digits? So for the thousands position, we can choose any number from 1 to 9, that's 9 choices. And for the hundreds position, we still have 9 choices. We can't choose the number we chose for the thousands position, but we can choose any other number from 0 to 9, so that's still 9 choices. And for the 10th position, because we already chose 2 numbers from 0 to 9, so we are left with 8 choices. Similarly, for the unit position, we are left with 7 numbers to choose from. So the total of the multiplication will be the total number of the digits of the integers that have 4 distinct digits, and that's 4, 5, 3, 6. The answer is B.